be a plane through the origin in R3? Is P a subspace of R3? Before we go ahead and actually decide formally, I want to give us an idea using a visualization. The first thing we need to check is that if we add two vectors in our plane, we get somebody that's still in our plane. I have two such vectors here. Using the parallelogram rule, I can add them together to get this solid vector. As we can see, this solid vector is still in the plane. And the same is true when I move these vectors around. This suggests, but doesn't prove, that our plane is closed under addition. The second thing we need to check is that if I take a vector in our plane and scale it, I get a vector that's still in our plane. I have such a vector here. Scaling this vector a bit, we can see that I do indeed get somebody in our plane. And the same is true with other scaling factors and with other vectors in our plane. This suggests, but again does not prove, that our plane is closed under scalar multiplication. And finally, together with our observation about scalar addition, this suggests, but as I've said a bunch of times before, does not prove that our plane is indeed a subspace of R3. You may be asking yourself, well, didn't we just prove that it's a subspace? Didn't we just do that? We just showed that if we take these two vectors in our plane and add them together, we get something else in the plane. And if I take a vector in the plane and scale it, then I get somebody who's still in the plane. Problem is, we didn't show those things for every vector in the plane, for every pair of vectors in the plane. We only showed them for the ones we showed them for. That's why we need to do things rigorously. However, we can use what we just did as a way to build our intuition, as a way to suggest, okay, I'm pretty sure that the answer is that P is indeed a subspace. So let's go ahead and check to see that it is. Well, to do this, suppose U1 and U2 are direction vectors for our plane. From what we know about spans, this tells us that P, that's a bad P, let me redraw that, that P is the span of U1 and U2. Okay, now I've said a few times the first thing we should check is the zero vector actually in our plane? Well, it is, because this is a plane through the origin. Okay, let's now check to see, is this closed under vector addition? Let V and W be in P. We want to show that V plus W is still in P. Well, we can use the fact that we know that both V and W are in P and that P can be written as the span of U1 and U2 to help us. V is C1 U1 plus C2 U2 for some real numbers C1 and C2. And similarly, W is, say, D1 U1 plus D2 U2 for some real numbers D1 and D2. Putting those together, we see that V plus W, let me put a little therefore symbol here, therefore V plus W is equal to, let's see, C1 plus D1 times U1 plus C2 plus D2 times U2. Aha! Since C1 plus D1 and C2 plus D2 are both real numbers, that means that this expression, and therefore V plus W, is indeed in P, because remember, P is the span of U1 and U2. Therefore, we conclude that indeed P, therefore symbol P, is closed under vector addition. How about scalar multiplication? Let V be in P, and let K be in R. We want to show that K times V is in P. We can do the same starting point as we did in the addition part, using the fact that V is in the span of U1 and U2. We can write V equal C1 U1 plus C2 U2, and then KV is equal to K times C1 times U1 plus K C2 times U2. Aha! KC1 and KC2 are both real numbers, and so therefore this expression is also in the span of U1 and U2, in other words, is also in P. So therefore, P is closed under scalar multiplication. Thus we conclude, therefore, P is a subspace of R3. Generalizing the above method that we just used for proving that a plane through the origin is a subspace, we can in fact show a theorem. If V1 through Vk are vectors in Rn, then span of V1 through Vk is a subspace of Rn. And so we call span of V1 through Vk the subspace spanned by V1 through Vk. Okay, well, I already have the word span. I already say, okay, this is the span of V1 through Vk. Well, sometimes I want to emphasize the fact that it's a subspace, so I'll say it's the subspace spanned by V1 through Vk, and this is what I mean.